Okay, so I hope everything is working well. Let's see. So the idea was to fix the gap and also the terrain generation to make it sure there is no gap ever. So the first thing I'm going to do is just to create a branch so that we can push it whenever we want. And let me push it. Just a second. Thank you, Grants. Welcome. I'm still new to this, so let's see. I just have an issue with Git. Okay, it seems my key was not saved. Oops, wrong. Sorry for that. Okay, that should be fine now. So let's try again. And this time it's working. So anyone who wants, you can use the UFO gap fix one. For now, it's just the same as master, but with the last fix from Calibre merged, which make it quite a lot faster. So it's I think it's important to use it. So let's go to the real stuff. So just sanity check, as Hardy say, see if it's still working. So it's working fine. I think here we see the kind of gap that I want to fix. And so so the main reason why there is gap like that is because basically the mesh that are supposed to be close together are not exactly at the right positions, and it's actually not possible to have them always at the right position. For the road, it was quite easy to do it with just fixing the shader, but for a work like that, it would be not the best solution. And also we had to disable batching, and in this scene, if we disable batching, I think the performance would be quite bad. So the idea I have is basically to replace this simple set of triangles with a mesh that we generate in the code, and this way we can be sure that the point will match exactly. And so I had a look at in Unity. You can create a mesh by just a few lines of code. So you basically have to set a list of vertices and then triangles. And with that, we could replace the mesh that we use for the tile with a mesh that will exactly match. So let's see if we can do that. And yeah, we can start with a simple test to see if we can replace the mesh of the tiles with just one quad like that. So let's open the terrain generation stuff. I think it's this one. Okay, so basically this those two lines are the ones that creates each tile, and what we want is basically replace the mesh in that one with a mesh that is exactly at the right position, and this way we also no longer need the transformation, because that's also a source of gaps because they don't match between different tiles. So we can try to integrate the similar code as what was shown in the Unity page. Let's start with a quite just to test. I think it will actually be similar. And that can actually go between -1 and 1. Actually in X and Y and Z, sorry. -1, -1, 1. 0, 1, and put that in the mesh vertices, then the triangles. So normal. We'll put that in another method when it works, but yeah, that's a potential idea, yeah, to combine the mesh. It could actually be quite easy, but we can do it step by step. First, changing the mesh for each tile, and then we could actually generate one single mesh for the tiles in the same chunk. And that would be the quite efficient solution. So the normals should be 2r plus y. I don't know if there is it's probably the up vector. And then when this is done, we just have to put the mesh to replace the one that is in the mesh filter that we took here. Okay, so let's see if that works. No. Okay, I'm not sure if this notation is... to me that should be something like that. Okay, it compiles. So if it works, we should see quads, yeah, instead of the tiles. So basically here we generated a different mesh, so it's not the one that we want, but it shows that yeah, this approach of yeah, using a mesh that we compute ourselves can work. It's not that difficult. I thought it would take longer to get to that point. But let's see. So the whole point of generating the mesh is to get rid of all the transformation. So the idea is that we want to put that directly in the way we compute the mesh and have no transformation from the coordinates that we compute. So we can change that to basically no longer applying a transformation. So we would reset it to 0, and also the rotation. I think there was another part of the code that was changing the position of the tiles. It was could be this one or probably this one. Because I saw that yeah, this part I was not sure. Well, it's taking from an old tile. It may be okay. Yeah. Oh no, that's the one, yeah, that I wanted to change, because we don't want to do that anymore. But we should actually put, because that's the real position that is being used now. Wait, we are changing the wrong. Oh no, it's I was changing this method, so I know Y and X, so I could put these codes inside the Biome controller, except that we are no longer using it. Yeah, I'm not used to Visual Studio, but yeah, just a quick test. And so the idea is that we should actually we can we need those numbers. to have our base in what we compute here. So we can do a quick version first. Which is the same code. Hello, human. I'm trying out. So the idea is to replace that. Well, that we actually know it's offset height. These computations, we will need to do them in integer instead of floats to make sure they match. But for now, that's an easy solution. So basically, if we add the translation to the same points, so it would get translated, but the transformation would no longer be used. And one thing that we need to change is that previously the trees and so on were using the transformation from the tile, but now the tile is no longer transformed. So we basically need to not do that, but instead or we can still do that, but the idea is that we need to add also the transformation here. To keep the tree at the right place. So let's see if it still works. Seems to be fine. Just to check, yes, the tiles now have no transformation. So they are all basically giving to the graphic card exactly the position that we sent. So if we make sure we compute the position of the points that are shared between two tiles, then they will match perfectly and there will be no gap. But so now the next step is to replace the quads with an actual hexadecimal tile, hexahedral tile, sorry. The idea is also to do the computation of those positions using integers instead of floats. This way we can make it such that they match exactly between two tiles, and we convert them to floats just at the last time. Okay, so how do we do that? First, we need to see the coordinates of the tiles. So yeah, the number of draw calls could be reduced if we create one mesh for all the tiles of the same kinds, and could be quite easy, but we can do it in the second step because first we need to make one tile works, and then we can do many tiles in a single mesh. So the idea to create the positions that match exactly is to compute positions based on integers. So the tiles that we use, they can actually be put on a grid, and if we put them at the right size, so basically one tile, if it takes 4 grid cells in this direction and 2 grid cells in this direction, every vertex is exactly on a point of the grid, which means that we can compute those points using integer coordinates, and then we can, based on the scale, change it to the right values in the worlds. And so basically we have to generate 6 triangles, and there are some more, oops, like that. So you have a point that is in the middle, but it's also exactly in the grids. And so the idea is that, yeah, if we generate one tile like that, then if we just add 4, not actually 6 for the next tile horizontally. So if we create one tile every 6 in integer value, it will be like that. And then the one on the next line are shifted by 3 and one cell in this direction. And once it's done like that, then they will all match up exactly. So basically now we need to compute those coordinates. So the best is to compute the coordinate of the center in integer. Yes, 4x4 would work. Actually, once it's transformed in real coordinates, the grid is not the same. Like it's longer in this direction than in this direction. Like I'm saying, I looked at the mesh that Coke did, and there is like 50 units in this direction and 86 in this direction, something like that, which makes the aspect ratio a bit better. So let's compute that. I'll put it as a reference here. So the idea is that instead of working in float, I want to work in integer as long as possible. So basically the first that we can compute is the base x. That would be some value of x, and the base y would be some value of y. So as we said, in the x direction, we need we need 6 columns, so we need to multiply x by 6 to get a value that is here pushed like that. And in the y direction, we actually just need 1 because the one that are here is actually 2 rows below, because there is 1 row that is in between. So y is not multiplied, but the idea is that we need to do what was done here, which is basically to say that if every other line, we need to shift x by 3 to push it away. It's true that we could here do it in yeah, why not? So yeah, doing it with less with less triangle would be something we could put basically 1 triangle on each side, and then we just have a quad that we can, yeah, why not? Every small gain is good to take. So those coordinates basically would yeah, create integer coordinate of this guy. Or actually we could take whichever we want, but it's actually better to keep basically this as a center point, because like then when the like the 0, 0 point was in the center of the tile when we place a tree or something like that. So yeah, good suggestion, Amatoban. So now that here we have those this base, we need to generate the position of basically. So in this version, only 6. So this I'll compute later, and this we don't need anymore. So we will need 6 vertices for this mesh. So we have to change that to 6. And well, the easiest way to create the vex3 from the integer value would be to create a small helper method. Call it maybe grid X and grid Y, and then we will basically need to give him the scale in X, the scale in Y. Yeah, it's actually, yeah, and we need also the should I removed it? Yeah, it was a tile offset value. And this will just be grad X times scale X. The Y coordinate in world space is actually the offset in the vertical offset, and then grid Y times scale Y. Okay, so now we can basically replace that with something that is base X plus an offset that we will compute based on this, base Y plus an offset, and then we'll need to create for now that will be actually I think it's the spacing between each grid is 6 in Y coordinates, and scaling is 1 in the Y coordinates. But it could change. We will see if that match. Okay, I could actually get rid. Okay, so now if we go from this point to the other, so compared to this position, this point is minus 2 in the X coordinates and 0 in Y. I can actually was there a text? So that's 0. That's 1. 2. 3. 4. And 5. So 1 is -1, -1. 2 is +1, -1. 3 is +2, and nothing y. 4 is +1, +1. And 5 is -1, +1. Okay, so that should be our coordinates. Now we can generate triangles. So the triangles, there are 4. So we need 4 times 3 indices. And well, this is actually always the same for all tiles, so maybe we could compute it only once. But I think the real optimization is to do the mesh in a single go. So, and there we will need to compute it. Hey, Hardly. Yeah, if you're ready to stream, I can stop mine, or maybe just tell me and I'll see how to follow your stream while continuing working on that. But yeah, I'm trying a small experiment to generate the topology in an exact gap-free way. And I was trying to do so the 4 triangles. First one is 0, 1, 5. And I have basically one chance to have it the other way, but we'll see. The other one, so it's important here to always go in the same direction. Yeah, if I don't know if Unity is using clockwise or counterclockwise, but yeah, we will try clockwise, and if it does not work, we'll have to switch. Okay, so yeah, so the second triangle, 1, 2, 5. Fourth triangle, 5, 2, 4. And the last triangle, 2, 3, 4. And now we have to adjust the indices here. Okay, so that should be our triangles. So then we have the normals. So this is the same number as the points, and they actually all have the same normal. And so I need to change here. And the texture coordinates, for now we are not using them, but well, yeah, to have the grass, it can be good to use to have yeah, coordinates. So the base maybe is just to use the same value as the worlds, so we can do a quick loop. Is it size? No, length. And basically we will take the x and z coordinate from the vertices. And we'll have to apply some scaling later if the texture is too small or stuff like that. It's actually, I never programmed it in Unity and until going to Hardly's stream. But yeah, I've programmed a lot of OpenGL or other graphics programs. But actually never also in C#, always in C++, which is why some of the syntax I'm not sure. So let's see how that looks. Oh yeah, I said I'll have to recompute that. So basically the translation vector that we can use as a base for the object we spawn, we can compute it the same way as the vertices, but using the 0 offset. So this way this vector should match exactly the point that is here. Okay. Do I need to? Okay. Okay, let's see. Okay, so we don't see them because they are flipped, yes. And they are, yeah, there is another issue. But the first issue is, yeah, is to flip all the triangles. Even 50-50 chance. Hello, Swedish. Feels strange to be on the other side of the stream, but testing. Okay, so one part is generated correctly, but here we have only one row. Okay, let's see if we generate more. Could be related to the yeah, big gap. To the negative value, maybe. So can I click on one of them? They seem strange. Seems like they are like not. Oh yeah, no, they could be. Oh, I think the Y scale is actually not 1, but something else. So that we'll have to fix. But I want to see it in wireframe. Yeah, so we do have the tiles that match here. They are stretched, so not in the right way. And those tiles, oh, I know what it is. It's yeah, we can try. Those tiles are basically not offset, so it's basically they are overlapping instead of being offsetted by 3. And just a quick check, it could be because this test only works for positive numbers if y is negative. So the easiest way is to do it bitwise way, so just checking by an AND instead of a modulo. And that's the old assembler way, but it's also faster. If I can do that in let's this is not the AND operator. And that's fixed. So the scaling is wrong, probably, but the rest looks fine. So normally here there should never be any gap, but let's check. And one thing we did not generate is the borders. So basically there is a gap around the water because the water is a bit lower. But that we can fix by adding the border. It would actually be better to detect and put the border only when we are between a tile that is water and a tile that is not. Or we can just do the same as before and have the borders everywhere. Yeah, so the stretching is, I think, because I mixed up the scaling value that I used, so that we can fix. So those two values were supposed to scale it such that it matched the other mesh. But I think it's not, it's definitely not the right values. So going back to this, I think it might have been because there was a scale of 0.7. Shoot, I don't remember. Because it might have been only divided by 3 here. I think it might have been something like that. And here, well, how was it computed before? I think it was in, no, not here. This one. But I removed the code, yeah. So the it was 2 in the x direction and 0.6 in the y direction. So we are missing the 0.6. Let's try. So this one may have been right, but this one should have been 0.6. Okay, maybe this is more how it was. Seems to, around the water, it seems to be similar to how it was before. Okay, but so yeah, I could commit this version just because that would basically fix the gap. We haven't looked at the texture coordinates because I think I just put them quickly and they are probably too small. So this we can scale. I think it can be, well, we could add a parameter, or maybe the tile option in Unity might be enough to just change the scale of the texture, but just to get back to something that looks similar as it was before. think that's close enough, maybe. Okay. Oh, thanks for the roast, Hardly. So I can commit that, and anyone can test. Let me just check. Yeah, I didn't check how many triangles we are using before, but here basically we are should use much less triangle because we don't have the borders anymore, which is still we need to add here. But we also, at least we don't have them here, and the batching should be roughly the same. So we could optimize it to batch it manually to detect all the tiles that are of the same kinds in a given chunk and put them all in the same mesh instead of having many meshes that now have the same transformation and just different positions in the mesh. We could merge all of them, all of those that have the same material in a single mesh. But I think that's so here each tile is still a separate object, but there is nothing blocking from putting all of them in as many objects as there are different tiles materials. But that's I think it's just an optimization. I wanted to show basically how to simply remove gaps. Basically in this version, because the mesh is generated with a simple code that is easy to go through, the transforms are all gone. There should be no way for the graphic card to introduce any gaps anywhere. And to me, if the geometry is simple enough to be procedurally generated, then that's with this technique you can make sure you don't have any gap ever in your world. So let me commit that, and Hardly, if you want, you can you can take that. So I merge the earlier fix from caliber and merge your master, so you should be able to just take do a merge request with this branch. Let me just check what we changed. So we remove that code because now the generate tile handle everything related to the transform. And here, well, it's not pretty, but it works. We just have one function to go from our nice integer grid to the float values using the right scale and so on, but everything is in the integer grids. And this could be put a lot better, but basically for this simple geometry it works well enough. I think it could be if we merge by material, we need to find a way to add all the tiles of the same material at the same time, and that's basically why it's a bit not trivial to do it now, because of the system to not have too many tiles generated at the same frame. But I can. So I'll commit that, and I'll stop here for now. So maybe if Hardly you want to start on your end, and I may continue later, but I'm not sure because I would like to also watch what you are doing. But we'll see. The merging the meshes is definitely something that will be great to look at, but maybe not for the Ludum Dare. I mean, it's something that maybe we can have a look later, but it does not change the gameplay. So maybe we should focus on other things for the game. So we need the borders around the water and merge similar tiles in a single mesh. Okay, it's pushed. So thanks everyone. I think it's yeah, there was some good suggestion, and I wanted to check if how it feels to do trimming and how I can do it or not. I won't be able to do anywhere as much streaming as Hardly is doing, but maybe yeah, I could do some other sessions like that sometimes when there is a topic that is interesting to me. So yeah, thanks again everyone, and I guess we'll continue on Hardly's stream when he's getting started. Okay, and let's do a great game. Goodbye.